equals 2100 seconds. So my number of coulombs will equal 0.65 amps multiplied by 2100 seconds. Which comes out to 1365 coulombs. Okay? Once I get that, my next step is, how many moles of electrons are involved? So, the moles of electrons equals the coulombs divided by 96,500. Okay? So if I take 1365 divided by 96,500, I come up with 0.0141. Moles of electrons. Okay, that'll give me my number of moles of electrons. Now, since each nickel involves 2 electrons, she told you I was going to need that 2 somewhere along the line. Since each nickel involves 2 electrons, if I know the number of moles of electrons, if I divide that in half, that's going to give me the moles of nickel. Okay? So, the moles of nickel will equal what I got here, 0.0141, divided by 2. Because there's 2 electrons involved. If there were 3 electrons involved, I divide by 3. So I'm going to take now 0.141 divided by 0.0141 divided by 2. Comes out to about 7.05, and it comes out in scientific notation on my calculator, 7.05 times 10 to the negative third moles of nickel. Okay, 0.00705. It's the same thing that we got. I would convert that to grams. What do I do? Find the mass of nickel, multiply it by that, right? Well, the mass of nickel from the periodic table here, what does it give us here? Let's see, nickel is 59. Okay. So, the grams of nickel will equal the moles, 7.05 times 10 to the minus third moles, multiplied by, I forgot the number already, 60.
No.
59? My part-timers coming in. It multiplied by 59 grams per mole. So, comes out to 0.416 grams.
Okay.
0.416 grams of nickel. Again, look at what was done in the problem to figure it out. Okay, first I found out how much electricity I used. I converted that electricity to moles by dividing by the standard, which is 96,500. Once I get the moles of electrons, half of that is going to be the moles of nickel. And then once I find the moles of nickel, I can find the grams of nickel. That's the whole idea behind this course and behind a lot of the courses you're going to take in the future. What have I got? How can I use it to figure out what I need? All right. Next one. Will each each of the following reactions occur spontaneously or not? Let's take 8. What I'm going to do with 8 is I'm going to write oxidations and reductions. Okay? So I'm going to take the iron. It's going to go from Fe to Fe plus 2. Okay? That's an oxidation, so 2 electrons going right. The tin is going to go from Sn I'm going to gain 2 electrons, producing Sn. That's reduction. I go to my chart. I'm going to look these up. Okay. I'm going to look up, first I'll look up the reduction, because that's the easy one, because this is a reduction chart. So I'm going to look up the Sn, and I see that Sn plus 2 to Sn is minus 0.136. I'm going to look up the iron, and I'm going to reverse that, because it's an oxidation. So I'm going to look up the iron, and it is a negative 0.44, but I'm going to reverse that, so I'm going to make it plus 0.44. And then I'll add the 2 together. And if I do that, I come out with a positive 0.304 volts. Since I came out with a positive voltage, the reaction is spontaneous. Okay, if the voltage, when I'm done, if the voltage is positive, the reaction is spontaneous. See what happens with B. I got the zinc going from Zn to Zn plus 2. That's my oxidation. The reduction is the Sn plus 4 then. Oh, I'm sorry, did I go ahead? Yeah, I'm sorry, I dropped magnesium aluminum. Let's do magnesium aluminum. Yeah, this is the wrong one. Okay. The oxidation, according to that, is the magnesium, going from 0 to plus 2. So it's Mg goes to Mg plus 2. 2 electrons, right? The aluminum goes from Al plus 3. It's going to gain 3 electrons. It's going to go to Al. The aluminum's reduction, so I'll look that up directly as it is. And if I do, the aluminum comes out to be minus 1.66. So that one's fine. Leave it the way it is here. The magnesium I'm going to turn around. And the magnesium is minus 2.37, so I'm going to make that plus 2.37.